Alright, hi, this is Automatic Control Principles and Practices, Chapter 6, Mechanical Components. Measuring mean with the control of the converts the magnitude of the control variable to neither the mechanical or the electrical signal. The majority of the case of mechanical input signal is the pressure which they apply with the diaphragm bellow of the board and turbo to convert into the force or position. With the occasional force or position is obtained without conversion with the deflection by a metallic element with the displacement over the flow over the lever control of the however even the secondary conversion into mechanical or electrical signal is usually desirable. With the mechanical system generally with the hydraulic and pneumatic fluids. With the figure 6.1 show the most common components of such control system: diaphragm, bellows, pneumatic, and hydraulic. Hydraulic have the nozzle flapper, jet pipe, and pneumatic to the nozzle flapper. The nozzle flapper, pilot valve, and floorway, also made by hydraulic jet pipe. And then pilot valve and nozzle flapper to the diaphragm, jet pipe, four-way valve to the cylinder. The pneumatic system, for example, the deflection of the bell, the position flapper, the flapper, and valve, the combination result with the change with the pressure of the secondary air supply, which is applied to diaphragm final control element in order to amplify with the output of the flapper, now with the pilot valve, and the valve with the connect with between input with the final diaphragm, and most cases the pressure which is applied to the bellows and the input signal of the controller can be either directly over the diaphragm final control element, the resulting simplification of the desired however the many with the case of the primary signal would not be powerful enough for either further limit the possibility of the control of the action proportional position reset with the rate of control of the hydraulic system. Flapper nozzle with maybe due to the connection of the four-way valve of the oar and the import force of the high enough of the flapper of the nozzle stay with the eliminated with the four-way valve position, the directly cylinder actuating position, which is linked to the final control element of the position through the four-way valve with another with a delay for the jet pipe through the either the position of the actuating position with the direct with the active of the four-way valve. Internal feedback and arrangement proceed with the numerous interconnection with the repetition of all of these components with the flapper nozzle maybe due with the measuring the mains. Again, with the controller, again, with the proposition of the final control, and with the description variable component of the succeeding page of the layer largely ordered the outline. Figure 6.1 exemption with the made is only with the one element, probably the most universally, with the spring with it will be discussed layer springs. Only with the most universal element is mechanical control element, with the spring with the helical spring with the deflection of the proportion with the force applied with the written equation that is the spring as the F is equal to force over the time of the spring rate in pounds and inches, and with the deflection times X for the deflection in inches. The equation that's done with Hooke's law is available with elastic limits with the spring with a practical behavior. The spring does not necessarily follow with completely at either light with the Hooke's law with the deviation of the linearity as much as 5%. With the total deflection must be expected with the spring rate is given as K the spring rate in pounds per inch with the equal to torsional modulus of rigidity, which is steel wire, approximately 111 million and a half times d to the fourth diameter of spring wire in inches times 8 times d the coil diameter as shown to d to the third or the coil inches and the third inches to the third, and then times n the number of the active coil. Equation show the minutes and chamber of the coil diameter, even smaller chamber of the spring wire diagram will helical spring. Produce large changes of the spring rate of the medium of the region for the difficult with the control spring rate with the production. The usual method to select with the production run with the come close with the specified with the spring rate with the deviation. Figure 5% of the spring rate are generally accepted. Above the equation also show with the spring rate inversely with the proportion of the number of the coil thereby possibly increase the spring rate with the cutting of the oil out of the coils. For example, the decrease the number of the coil with a 50% increase the spring ratio with the twofold helical springs or the compression spring with the tension springs as shown in figure 6.3 with above the mention of the equation of the valve with either the form of the deflection or for the compression as with the tension. Figure 6.4 illustrates the difference between spring rate and the spring 4 for the graphic 1 shows the spring rate at 100 pounds an inch of the corresponding with the spring with 7 coils. This is the same spring has 10 coils would have the spring ratio of 70 pounds an inch. Illustrated with the graphic 2 with the using however show with the 6.3 show with the tension compression spring with the tension and compression with the weight end on a hook. Pounds per force 1, 2, and 3 and 0 to 100 and tenths and an inch deflection in tenths of an inch spring rate force. 7 coils are percussing with the spring with a 3/10 of an inch increase with the spring force corresponding shown figure 3. Spring is made with the combined either shear with the parallel arrangement with the basic combination seen in figure 6.5 with the cases A with the shear with the connection with the 2 coils spring rate K1 and K2. Combined spring with the K is smaller than either than K1 or K2 with the can be calculated by the equation K is equal to 1 over 1K over 1K plus 1 over 1K2. Cases B and C for parallel connections since each coil acts on the weight. Shift of the weight and mechanical components of spring A, B, and C. Directly the total spring rate with the sum of the individual spring rates with the K is equal to K1 plus K2. Frequently spring with the U with the connection of the levers are shown in figure 6.3. Sorry, for 6.6, the force are exerted by the weight on the spring in this case. Shows a weight on a stick and then a spring on a lever. As A is W with the balance of the spring with the force equal to the Kx, increase with the lever with spring force with the case for the B, increase with the acting force. M over N, small M with the deflection spring with the same motion with the lever, also called the M over the small N, heights the weight with the now becomes the balance of the spring, which is equal to M over small M times K over M times M, small M times X, or equal to F is equal to M2 over M minor M2 divide times X K and X, which show the effect of the lever increase the spring rate with the effectively equal to the share of the lever ratio of diaphragms. Alright, pressure applied within the area of the force of the P is times A with the equal to F. This means the only pressure is given the force of the derived with the effect of the air with the pressure is applied with the diaphragm U with the effect of the air left in the actual area with the diaphragm and the pressure acting on the diaphragm shown in figure 6.7. The produces a force pressure then with the diaphragm and then the with the diaphragm system. This absorbed part of the clamping of the peripheral over the diaphragm with the remaining force of the action availability compressed with the spring with the slack diaphragm. The diaphragm of sheep and goat skin leather are probably the most sensitive to have the synthetic material generally with the fabricated layer with the largely supersede with the leather diaphragm. These convulsions either model with the material sufficient slackness and to provide with the convulsions form with the pressure loading. Considering the lowest part of the revolution of the diaphragm and the effect of the diameter of the diameter change with the illustrated figure 6.8 show the different variants of deflection of the diaphragm. The mid position is illustrated in figure 6.8a and 6.8b. Pressure is increased with the move of the diaphragm upward due to the force of the spring with which now show the change with the slope of the convulsion. As of the consequence of the new shape of the convulsion, the effect of the diameter increased with the conversely with the figure 6.8, but the pressure has increased with the diaphragm has moved it downward with the convulsion is now such a shape of the effect of the diameter has decreased with the after change of the square diameter, hence of the relatively small with the change of the effect of the diameter considerably more pronounced effect of the area, hence with the force of the process reduced with the pressure applied with the diaphragm and the change of the effect of the diameter, hence with the effect of the area with the result of the force no longer proportional with the pressure for the nonlinear element with the result of the order to minimize the non-inflected and linear effect of the stroke should be reduced to a minimum and not always possible with a particular with the spring upward with the diaphragm valve with the valve with a stroke with frequently 2 or more inches and such a case the convulsions are made relatively deeply reduced shifting of the effect of the diameter of the side of the effect of the insofar will produce a slightly different shape of the valve convulsion depending on whether the valve moves upward or downward. Consequently with the equivalent backlash of the bellow frames in order to increase the linear effect of the diaphragm the bellow frame corporation developed a particular shape of the diaphragm called the bellow frame in which the deep convulsion of the model is synthetic diaphragm rolls between the two surfaces illustrated in figure 5.6.9. Effective areas maintain constant with all the practical purposes and show the automatic controller in a bellow frame. Metal diaphragm, slack diaphragm has a pressure rating with the general limits of the pressure of 20 psi or 11. The most diaphragms are limited within this respect. Structural rigidity advantage with the design component with the general they can be used without counteracting springs. Metallic diaphragms of the makeup of the nonlinear become with the rapid between the effect within the deflection that may be made negligible to reduce the deflection for a plate, but the diaphragms must now be deflect with more than 1/3 over their thickness for the means of the motion in the order of the thousandth of an inch, which was quite inacceptable to many of the components in order to improve the linearity over the somewhat longer strokes. Corrugated metal diaphragms are frequently used, but the corrugations are generally concentric. Bellows further increase the deflect with the relatively rigid with a comparatively high pressure rating with the character of the bellow with the valve with the deflect with the or unit chain with the pressure. The function of the number of the corrugated with the spring rate of the area with the bell with the typical bell with the must have the spring ratio of 600 pounds an inch corrugation with the providing 10 convulsion with a spring rate of 60 pounds an inch result of the list of the air bell with the 3/10 of a square inch over the pressure chain with the 20 psi with the bells will be deflected with 1/10 of an inch. Hysteria with the nonlinear several percent of the maximum stroke that may have with expected with the bell to improve the performance of the helical spring with the E with the parallel with the bell with the spring rate over the helical spring should be 10 times of the bell with the flapper nozzle with the illustrated figure 610 and adjustment area and flow pass with the respect with the behaviors like of the valve with this advantage is show the meter and the flapper nozzle with up against a flat medium over the valve with the simplicity with the construct with the smallest force of the required with the position with adjustable flow restriction with the flapper nozzle with the sphere with the fixed restriction supplies air into the flex ratio with the absolute pressure with the drop of the pressure S to the pressure T passing through fixed restriction of the from pressure T to pressure R for passing through with the nozzle restriction on passes negligible length is considered and and orifice of the apply with both fixed and adjustable restriction to the flow, whether it comes from the fixed restriction, leave at the root of the nozzle. Rate of Q air for flow with approximately measured as Q is equal to K times A1 over the square root of the PSI minus P2 times P2, or KA squared is equal to square root of PT minus PR equal to times PR. All pressure for the absolute pressure of the A1 and A2 the air are fixed or restricted to the nozzle respectively with the K's and the constant depends the flow pattern of the condition of the fluid above the equation can be written and it shows that after squaring and rearranging the equations of the result, solving the equation, and one only solution of the however, given the positive result of the therefore only with the practical significant equation therefore becomes is above the supply pressure of 30 psi A with the reference pressure of the atmospheric approximately 15 psi. Insert the values in the above the equation gives the area A2 the chamber that means the flapper. Hence the ratio between A2 and A1 can assume the value with a certain limits. Suppose A2 varies of the 2/10 for the A1 and 2 A1. Normal A2 over A1 ratios can be assumed with these limit the corresponding magnitudes of P2 with the calculated with the nozzle back pressure. The expressed with the gauge pressure is approximately equal to P2 minus 15. Following table computed values above conditions shows AT over A1 and then PT to 29.3 to 18.5 nozzle back pressure and PSI 14.3 to 3.5. These values apply over the curve of the figure 611 show how the nozzle back pressure for the position of the flap of the curve of the illustrator of the non-linear relation, but also makes clear that the linear has improved considerably operating only over the limited range of the H of the area of the ratio from A2 to A1, 1/2 with the A2 with the A1 with the 1.4 with the result of the corresponding small chamber. This is one of the reasons for the pilot valve to describe the areas of the multitude with the signal of the nozzle back pressure changing from 3 to 15 psi controller output signal ranging with the nozzle diameter in order to magnitude of 1/64 of an inch of the show the nozzle back pressure of 0 to 16 over 2/10 for the bottom degrees of change over the A2 over the A1. Respond to the air pressure of the nozzle opening of the 2/10,000ths of the inch, square inch of the center of the force of the stream input and pinning the flapper approximately equal to P2 over times A2. Maximum force may result of the flapper the completely nozzle over 3,000 of the pound. Actually, even the minimum minute of the force to obtain with and become the nozzle is over the partially open and only over the handle. Simple fact with the force exhibit the points. Certain limitation for the example the nozzle opening should be increased with 1/8 of an inch for the force of the wood increased with 64 times would no longer be negligible. Similarly, air pressure can be handled cannot be increased indefinitely. Another reason for the operating small nozzle diameters. Low nozzle back pressure reduce the air consumption increases in general with the consumption in order to 1 to 2 stand with the cubic feet an hour. For this purpose, the 6 or if it generally is 1 to 1 over 100 and 128 of an inch diameter. The flow rate. Flow passes through the nozzle, the impinges of the flapper over the deflect with the right angle through the area of the given between the circumference of the nozzle opening with the difference distance of the S between the flapper and the nozzle. Figure 610. Considering fixed orifice the figure 1/28 of an inch for the diameter of the corresponding area approximately to 100 and 0.0005 square inches for a nozzle, 1/64 of an inch diameter circumference of 5/100ths of an inch for the area ratio of A2 over the A1, 2 but the distance would be S would be given and is 2,000 of an inch clearance. And in fact, with some small non-practical close nozzle tighter than this, previous calculation is shown for the supply pressure of 15 psi or 30 psi A. Nozzle back pressure for the area ratio of 3.5 psi with a consequently even the maximum back pressure in the flapper nozzle. In order to obtain 15 psi maximum control output signal with the amplification factor of 15 over 3.5 is 4.3 required in the pilot valve for a maximum output of 3 psi nozzle back pressure of 7/10 of the psi would then be required with the equation 62 would be computed with the nozzle back pressure as a result of the area ratio of approximately A2 with the A1 over 3 with the negative distance between the flapper and the nozzle. In other words, the flapper motion of 3/10 of an inch of the over 2 minus 2/10 of an inch is 1/10 of an 1,000 of an inch. Sorry, 3,000 of an inch minus 2,000 of an inch equals 1,000 of an inch, and the range regulates the control output signal over the entire range. Small range of this flapper motion of 6/10,000ths of an inch, or no more, means unknown. The fluid flapper nozzle that described was air and any other gas for the flapper nozzle could be even used liquids, especially for the hydraulic oil. The characters similar, even though the flow equations given above do not apply hydraulic operation of the flapper nozzle. Is however it is difficult with the high pressure occurring with the hydraulics to produce the flapper of the flapper, which are no longer negligible. Furthermore, it is more difficult to keep oil clean than air with an extremely small the diameter flow resistance clog easily unless the impurities are continuously removed. Right, other forms of the flapper nozzle. The figure 612 show the push pull with arrangement of flapper nozzle when the flapper nozzle moves toward one. Moves as away from the other with the effect of therefore is increase the nozzle back pressure of the one at the time as the decrease on it. But this is a push pull flapper nozzle. The other pilot valve must be designed with the operator with the pressure differential with the push-pull flapper nozzle with occasionally with the hydraulic stroke with the differential pressure with the valve with the supply with the crown with the spool with the four-way valve with the figure 6-4-13. Show the a free vane principle with the Bristol Co. and the vane takes the place of the flapper. The main advantage is the flow. They show the free vane principle supply output signal. Forces on the vane with a minimum, they cover the motion over the vane vertical with the airstream, letting with the nozzle sideways, force of the balance over each of the two devices nozzle design. The edge of the vane is between the two nozzles. The operates a motion of 5,000 for the inch, changing the nozzle back to pressure of 4.5 to 5 psi. Other pneumatic flow restriction orifices is only one with the providing to restrict the pneumatic circuit. The other method of the inserting length of the tube with the considerable reduce the diameter, and so called the capillary flow through capillary valve with this equation. The merit is equal to 10,142,220 times D4 plus times P1 minus P2 over the N after the capillary and velocity of the liquid times the length of the capillary in inches. Where Q is equal to the flow in the cubic inch of the distance of the diameter, capillary inch of the P, and P2 for the pressure and pinches before and after the capillary, and if the integral velocity of the fluid with the center pole with an L with the length of the capillary in inches. So the equation of the diameter appeared with the fourth power, that is readily seen with the degree of the diameter with the rate of the flow, with the diminution of the rapidly, with the also inch of the flow, with the inversely with the proportional. The length of the capillary provided with the possibility of adjusting the flow rate with the length of the shortening of the capillary. Another means of providing a flow restriction in the needle valve that is in flow with express, and then it shows the M is M, where M and L and D and L and D are shown. Figure 614 expressed with the inch of the angle A, also shown in figure 614 expressed. Alright, show the needle valve. Degrees. The viscosity N is the center probe and the flow of the Q and the cubic inch of the minute adjusted evenly made with the one or two turns of the needle valve. Handle covers a 500 to 1. Pilot valves. The pilot valve with a pneumatic amplifier with a flapper nozzle is designed with a small flow capacity, fast action final control elements, larger capacity density with further and limited pressure range with the flapper nozzle with the required the amplification. Two basic types of the pilot valves are either the continuous bleed with the O and the end of the non-bleed type of the continuous bleed type of the illustrated figure for 615 with the advanced simplicity construction of the nozzle back with the pressure and with the percentage of the element within this case of the diaphragm. Reciprocal plug with its connected to the diaphragm with the means of the valve stem with the illustrated position to exist with the connection atmosphere with the clove with the plug with the control output signal with the consider the undiminished air supply pressure. In this position, nozzle with which the pilot valve is connected to the obviously wide open and center of the diaphragm and the pilot valve is not deflected at all should the show the diaphragm to the nozzle, the diaphragm valve with the plug and the air supply controller output signal to the atmosphere, valve plug in motion with the controller and signals in PSI versus valve plug in motion in inches. Supply adjustable resistor supply port to controller output. Also the exhaust port, adjustable resistor atmosphere. Nozzle back pressure. Then keep the flapper move the closure of the toe of the nozzle of the diaphragm would it deflect with the valve plug. Would it leave it particularly open with the pore with the atmosphere closed with the corresponding amount with the pore that admits the air from the supply line. Maximum deflection with the pilot valve of the diaphragm would block off the air supply with the relief the L exit of the air with the controller output signal line with the reduce the signal atmospheric pressure. Intermediate position pilot valve of the diaphragm produce the intermediate single pressure in the output with the shown figure diaphragm 615 supply port over the exhaust port. Or two resistance to over the airflow may flow with the pressure between the two resistance with the control output pressure of the single supply port resistance of the exhaust port resistance may be visualized being coupled together so that one resistance greater than the other diminished for the automatically vice versa. The non-linear between the valve plug and the motion control of the output signal with the considered is shown 615 hence for the general with the formula on from on and off control of the valve plug and assumed either fully open and fully closed position satisfactory with linearity. However, the computer obtained with the feedback method the general procedure is and convert control output signal in the position by deflecting the bell of the proportional to the pressure. Position is compared with the flapper position as described in Chapter 8 with the non-linear to the pilot valve. There's no effect in this case. Figure 616 illustrates the action non-bleed type of storm that support with the nozzle back pressure and creep with the do with the flapper approaching the nozzle. Shift the nozzle up with the diaphragm, lower fire diaphragm, the valve plug with the atmosphere with the end to the controller output signal with the air supply with the spring while the valve plug. This will deflect with the upper diaphragm and the pilot valve with the width with the lower diaphragm and assume with the amplification chamber the nozzle back pressure pipe for the tank, the plate for the pilot valve, although would be required for the purpose of the lower diaphragm and the small area of the upper one of the diaphragm, assumed with the move of the downward of the valve plug, also the push down with the action result of the opening valve port with the emission of supply air in the signal line with the signal pressure, which if the now rising and pushing against the lower diaphragm and over the signal pressure for this increase sufficiently to an equal with the nozzle back pressure applied with the upper diaphragm, force to cover the diaphragm and balance valve is closed again with the all condition the same as shown with the figure 616. Single pressure controller output is now with a higher value with a nonlinear diaphragm response and the character of the pilot valve does not increase the action when the nozzle back pressure increase the diaphragm to deflect with the upward open to the outlet port with the atmosphere single line with the releases through the air releases air through the port with the force of balance across the diaphragm is established. Outlet port of atmosphere is then again closed. Non-bleed pilot valve required with the compressed bias ring, the press for the valve plug again for the port illustrated with the figure 616 with the force exerted with the nozzle back pressure to deflect with the diaphragm downward must be equal to single pressure in time with the effect of the air with the diaphragm plus for the force as a result of the pre-compression of the spring. This is out with the nozzle back pressure to create the diaphragm and then moves upward in action force with only with the controller output signal applied with the lower diaphragm. Spring force does not enter with the additional spring force with the pressure they active with the crowd with the supply with the exhaust plug with calling supply pressure PS and then controller output signal PC. The atmospheric pressure PR and the air with the diaphragm AD and the area of the supply plug AS, exhaust plug AE, spring force due to the compression FS, total force active in the downward direction, in this case small increase with the nozzle back pressure. And then the formula, which in this case small decrease with the nozzle back pressure forces upward directions are, and hence the nozzle pressure change the amount equal to the difference between 6.4 and 6.3 without moving the diaphragm and without changing the controller output. Signal dead zone with thus created, which can be minimized with the design but not eliminated. The capacity of the non-bleed pilot valve is generally larger than that of the continuous bleed pilot valve with a good design with a non-bleed time. It takes 15 seconds to build up pressure for the fleet at 15 psi with 300 cubic feet in volume. Continuous bleed type of the maybe need 3 to 4 times that much. Alright, jet pipe. With the widely used hydraulic control system, figure 617, the illustrate for the jet pipe, it acts in conventional form of the jet pipe swing with a vertical plane over the round the horizontal axis supposed on the left of the barrel, bearing pipe on the right of the sleeve, bearing through the which of the minute amount of the oil is allowed to leak. In the common sump is now shown with the method of all of the but eliminating the friction over the suspension over the pressure of the oil is pumped through the jet pipe. It depends on the application, usually somewhere between 100 and 400 psi with the constant predetermined pressure for the jet pipe, the oil with the direct for the two closely adjacent receiving orifices in the distributor block, which air in turn will connect with the opposite end of the actuating cylinder pipe. When the pipe is in mid position, same pressure exists in either. So the signal force and then the actuating cylinder jet pipe, the distributive block, actuating cylinder, resurfacing orifices subsequently pressed with either side of the actuating piston are equal to slight deflection of the jet pipe with the orifice. One orifice will receive more oil than the other, creating a difference in pressure between the two ends of the actuating cylinder called the piston to move the respond with the jet pipe deflection. As the oil leaves, converting the jet pipe tip of the potential energy chain with the kinetic energy of the enter for the receiver of the oil with the kinetic energy of the chain with the potential energy of the version of the oil with the pressure of the velocity pressure jet stream between the jet pipe and the tip of the receiver of the oil with the subsequent with the reconversion with the static recover the pressure with the result of the current pressure level with the recover the generally becoming 85 to 96% of this meaning within 100 psi supply pressure for the pressure of the actuating position if the 85 to 96 psi when the jet pipe is fully deflected. Relation between the jet pipe to displacement and static recovery pressure for the preserving the orifice zone, figure 618 with the unit of the normal operation of the jet pipe with the deflection limited to the mechanical stoppage of about 35 hundredths of an inch on either side of the center of the action with linear under around mid position nonlinear creeping and over the extreme. Mechanical components show the static recovery pressure in PSI, that's 20, 40, 60, 80, 100. P1, P2, X in the orifice, and then 0 to negative tenths to the left, negative 10, positive tenths to the right. And jet pipe deflection. Various pipe tips available to typical size corresponding flow, cubic inch minute, various supply pressures at 100 psi, 200, 300, and 400 psi jet types at 5 hundredths of an inch, 65 hundredths, 80 hundredths, and 1 hundredths of an inch. Flow rates are shown applicable when the jet pipe does deflect with the actuating piston does not deliver the work of the measures low with the amplified with the piston low flow. Hence the speed of the piston, the creep of the illustrated figure 619 show the decreasing of the load flow of the load pressure as well as the different deflection of the jet pipe. One of the essential advantages of the jet pipe with the flow force of the practical with the non-existent of the hence of the operative with the very weak with the input signal with the other hand is limited with the power output. 4-way valves. When higher power output is needed, the four-way valve is the most frequently used component with the hydraulic screw. The frequently positioned with the jet pipe with the flapper nozzle input signal is strong enough for the spool of the four-way valve that can be in position directly with the figure 6 drawing. Show the basic concept of the four-way valve in position. Show the load in inches and inches cubed by the minute with the load pressure and psi, and those are helical. And those are good quarter-inch circles. 0, 20, 40, 60, 30, 80, 100. 20, 40, 60, 80, 100 load pressure and PSI. Shift the drain supply, the spool, the input signal, and your 3 ports and 2 tube learn spool in that neutral position, and an actuating piston. Output. Shift the spool is placed to the left, and shift the input signal, the end drain supply, and the schematic drawing of the four-way valve. A certain hydraulic volume trapped on bolts over the actuating piston. Oh, shit. Actuating piston, the input signal that displaces the spool on the left of position B with the connection between the supply and the right side of the actuating cylinder establishes well with the connection between the left side of the drain, resulting pressure difference for the move of the piston to the left. Ideally speak for the spool with the neutral position should close the ports of the actuating cylinder side with the displacement should open them, or the manufacturer conditions can be hardly obtained with either overlapping underlap with the result of the illustrated figure 721. Should the underlap of the port supply drain port load support and port drain port load. To show the overlap and underlap of the drawing. When the overlap lands on the spool or wider the ports, therefore must be the certain the displacement over the spool before the plate ports are actually the opening with the perfect condition of the dead bandwidth over the obvious for the undesirable unlap condition is referred to the underlap condition produced the leakage of flow around the valve of the ports for the result of the basic chain of the web of the behavior of the valve of the load supplied to the actuating pivot the overload of the fixed position piston over the force of the hydraulic pressure available across the load. Simply to illustrate figure 619 when the jet pipe does not exist if the jet pipe under the condition the underlap of the condition however the bypass around the load exists as long as the displacement is no longer within the underlap of the bypass producing the pressure drop in the supply port with increase the load conditions illustrated figure 2 graph the figure 622 for the graph is published in J.L. Shear or the symbol X designated the spool displacement while for the valve with the 0 underlap that corresponds to the show the load flow in inches over the squared over the load pressure and PSI and supply pressure of the 950 PSI. And then load flow and supply pressure of 950 PSI, a valve underlap of 500ths. Upper diaphragm, the small with the displacement provided with the full brake loop with the pressure of 950 PSI, cover the actuating piston, underlap the illustrated in the load diagram characteristic chain complete with the plate displacement 100th of 1,000th of an inch maximum attainable pressure of only 250 PSI. Fluid passes for the ports of four-way valve cut the flow force across the spool axis. Figure 623 illustrates the flow through the valve port flow ends with a certain pressure of the velocity of the metering point. Port in and outlet port velocity is greatest because of the cross-sectional flow of the smallest. Hence, the static pressure at the metering port is smallest. On the other hand, the velocity is at the inlet port is comparatively low, and static pressure is very high. Therefore, high result of the pressure components along with the axis of the spool with the larger torque of the left and the right intended to close the valve examination. Figure 623 show the flow may be reversed without altering, and it shows the flow through the ports of four-way valve in the direction of flow force. The general statement that holds together with the flow force of opening the shut valve and magnitude of the expression of the assumption. Force of flow first, then Q is a flow in cubic inches a minute, and P1 and P2 pressure, initial pressure, and second, and drop through the port and PSI. Critical case pressure drop maybe to 90 PSI and flow of 500 cubic inches a minute. The resulting flow force would result in 1 weight of the pound. The question is basically the assumption of the diameter D with the figure is small compared to the diameter D. The piston spool making the D is larger and little minor D is larger than practical velocity inlet port that can be increased with the flow force of the degree forms correspondingly. Special valve core configurations have developed shown in figure 1.624 with dividing streamlined surface with the cancel most of the flow force and the relatively high cost machining necessary parts with the main disadvantage of the stuff of the construction. Hole and plug valve. Our special configuration four-way valve that has been developed with the Massachusetts Institute of Technology. The purpose of the design to make the valve with approach to the rear lap of the lower call for the possible the spool tail of the discuss is so far illustrated in figure 625 of the valve consists of the plate with the body with both made with a rectangular shaft with air flat with the ground surface facing each of the minimum of clearance. And then show the flow of the force compensating port of the four-way valve. Essentially, operation of the same four-way valve in and consider the relative of the displacement of the lane of the port difference for the two approaches of the line laser production. The method of the black parts of the Tiger 623 insert to prepare the holes of which they are inserted the valve plate with a line with the valve body with a hole drilled straight through. It's really easy with the making square port with the customary conventional spool valve with obtaining the flow versus the displacement relation. Such instance, insert the hole plug in the valve with a round with a displacement plate with a corresponding opening with a circular hole results in linear relations. Assuming the outer edge of the low cylindrical insert with a perfectly square with a surface of flat and inner space between the plate with the body negligible with a perfect zero flat with the zero is obtained some of the ideal conditions. However, the only a perfect is not attained with the relay solved behavior result of the underlapped valve. Figure cylinders, 626A single acting cylinder, 626B with a double acting cylinder with a flapper nozzle give the position. In this example, the other relays can be substituted in single acting, and then show the single acting, double acting signatures. Some of the nozzle back pressure of the balance spring with the actuating, some of the load on the piston, the disadvantage of the arrangement, a large loss of energy span with the compression spring, adjust advantage of the how for the number of the application, the fact with the spring provided with the safety feature for the given for the failure. In this case, the supply pressure for the failure of the spring will drive the actuating piston cylinder to the left. Double acting cylinder require the feedback arrangement in order to obtain with the position proportional to the nozzle back pressure for the arrangement with the show and the proportional speed flow and control. More advantage for the double acting cylinder that operates without spring with the nozzle back for pressure for the available in any position actuating against load. Chapter 7 Electrical Components.